My name is Xiu-Zhe, but people usually call me Roger. I'm currently living in Waterloo, Canada. I'm doing a physics PhD program, and I mainly study condensed matter and quantum information. I think software is a form of knowledge, and open sourcing the software can help to propagate the knowledge. And I think any public funded research and development should open source their software to make it more accessible. And this is how we actually pass the knowledge to next generation and to the future. Besides that, I love the culture of open source development. People from different backgrounds, from different places can collaborate online all together, working on cool projects. So when we start to develop Yao, there's no software for variational design for variational quantum algorithms. And my collaborators are doing research about this. So then we decide to write one just for, initially it's just for our own. And then later, after we actually use it in real research, and more and more people start using it. Besides Yao.jl, I also contributed to Flux, PyTorch, and even Dual language itself, and maybe some other projects as well. So I think GitHub says I had roughly 3,000 contributions in the past year. So that's probably it, but I can't really remember like what are all those projects. I guess I don't have a favorite one, even my own, because that's why I keep writing those packages. The quantum community actually already exists in Julia core developers since the language was born. For example, Jiahao Chen was doing quantum chemistry when he started doing Julia, developing Julia. And Stephen Johnson, who is now a professor in MIT, also does quantum optics. So there are many other people also doing quantum physics in Julia when this language was designed. So I came later in more like a quantum information or condensed matter guy, building tools for this field. And I kind of find collaborating with all these people very enjoyable. So I think then the quantum ecosystem just automatically, naturally emerged from the community. I think the future of quantum software is going to be composable, which means all the people just work on their own fields, and if you find there's a feature that interacts between both fields, you can just compose them directly instead of writing extra glue code. And the other thing is differentiable. So in recent years, a lot of people are very excited about differentiable programming, including Banjo, and people have been using this method in a bunch of research. So I believe in the future, differentiable programming and differentiable software is a very important direction. And this leads to more compiler-related software engineering in both quantum software and general software development. We have a channel in Julia Slack, so if you join the Julia community Slack, you can find us in the #YaoDev channel, or you can also join. You can also post issues under our repo, or you can also post things on Julia discourse. So I'm planning to do more science in my following PhD program. But I'm also planning to write a new compiler for the Yao ecosystem that actually compiles your code written in native Julia to an actual quantum hardware. We're still working on this.